So, I left up this operations with rational numbers because we haven't talked about multiplication or division yet. But, right now, I want to talk about primality, testing. Just means testing a number to see if it's prime. So let's just use 151. Like 151 looks like it might be prime to me. First of all, since it's odd, there's at least a chance of it being prime. If it was 152, I would know it's not prime because 2 would go into it. But this at least has a chance of being prime. So when you test to see if a number is prime, you want to know the square root of it. So what I'm going to do, find the square root of 151. I have an idea about what it is. So it's 12.288, and then it goes on and on. So 12.288. That just means approximately, if you didn't know. So I want to look at any prime number that's less than this number here. So 11, 7, 5, 3. You should know like some of the smaller prime numbers. So you don't have to test like everything. Like you don't have to say, well, do I have to test 10 and 9? Well, I know that the prime numbers less than this number are 11, 7, 5, 3, and 2. It's a good idea. I said it in the previous video, you should probably memorize or at least somehow know or be able to figure out any prime number that's less than 100. There are not too many. I should have looked that up. Like I said, I think there's in between 20 and 40. I know that's a pretty big range, but in other words, it's not a huge number. It's not like 90. So all you have to do is try to divide this number by these. And if any of these numbers goes into this evenly, then obviously it's not prime. But I'm going to use divisibility rules. I know this number is not divisible by 2 because it doesn't end in an even number. I add up the digits, they add up to 7, so 3 doesn't go into it. The last digit's not a 0 or a 5, so 5 doesn't go into it. I have to check 7 just by like doing 151 divided by 7. But I can do that in my head and it doesn't go in. Same with 11. 11 doesn't work. So 151 is prime. That means that I know this number here is not prime because it's even and bigger than 2. So these can't have any common factors. Oh, also this isn't a multiple of 151. If this was 151 over 302, then it would just simplify to 1/2. But this isn't a multiple, so this is in its lowest terms. Let's do another number. Let's check another number for primality. A bigger number, like 400. Like I said, it doesn't make sense for me to put an even number up there because it wouldn't be prime anyway. So 467, that looks like it's prime. I'm pretty good at guessing prime numbers. I don't want it. I'd like to do a few. Actually, I know one that I could try. I'd like one of them to actually come out to not be prime. This is probably prime though. So you take the square root of 467. Did I remember to write this radical sign around it before? Did I just write 151 as approximately 12.2? I don't know. I can look at it again and I'll point that out in the description of the video. You take the square root of the number. $21.61. Remember, this is approximate, not actually $21.61. So you're going to test all the prime numbers less than that. So it's 19, 17, 13, 11. Like I said, using divisibility rules, you can easily eliminate So we want to check to see, so now we're checking to see which of these numbers goes into 467. Not the square root of 467, but 467. 2 doesn't work. 5 doesn't work. Those are easy to get rid of. Just using our divisibility rules. 3. These digits don't add up to something that's divisible by 3. 7. We didn't talk about the divisibility rule for 7, but one thing you can do is just take 467 divided by 7. It doesn't come out to a whole number, so that doesn't work. 11's not going to work either. I know the divisibility rule for 11. Actually, I know it for 7 too, but I don't really want to get into it. 13, I used to know the rule for that. I'll admit that I don't know it right off the top of my head now. But I'll just divide 467 by 13. Doesn't work. How about 17? 467 divided by 17. Nope. 19. Watch. Hopefully, maybe this will work. Nope. So 467 is prime. Let's write that down. So 467 is prime. I didn't need to look it up on Google. I didn't need to check every number underneath it. Alright, so 561 is a common number to, I don't want to say it looks prime because it's pretty obvious it's not prime. But we're going to do the same thing we just did. Or are we? Are we going to do the same thing we just did? Where I figure out the square root of it? I don't think we are. I think I have an easier way to do it. The digits add up to 12, which means 3 goes into this number. So part of primality testing is just knowing, hey, that number can't be prime, divisible by 3. So this is not prime. You could do it the same way we just did though, where you do the square root, then test all the numbers. The first number you really test will be 3 and it will go in. Because you wouldn't test 2 because it's obviously not even. Alright, so I think I'm actually going to stop the video right there. We'll talk about operations with rational numbers, multiplication and division some other time. Yeah, my voice is starting to go away. So look for another video on this stuff right here. Operations with rational numbers, multiplication and division. Pretty soon. I don't know when, but soon enough.